Okay, 2.3, graphing equations of lines, okay? When we deal with graphs, every graph that we have has something called a parent function, okay? And we're going to refer to parent functions a lot. We're going to compare graphs to their parent function a lot. So you got to get familiar with what a parent function is. And a parent function is the most basic function in that family, okay? So you have the linear family, you have a quadratic family, you have those type of things. Every type of graph has a different family. Okay, absolute values, a graph we can do that has a family. So the parent function for a linear function is simply f of x, the function of x equals x. Okay, so that is when basically my y-intercept starts at 0 in this case, and my slope for x is 1. So I go up 1 over 1, up 1 over 1, up 1 over 1, the basic function of a line. Okay? You input, you get an output. You input, you get the same output. Boom, 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 boom. Okay? That is what all of my graphs in a linear function revolve around, is this parent function. Okay? So we're going to start comparing things to that. So, to start that, we are going to actually start by graphing. Okay? So we're going to graph these equations that are on the board. We're going to graph y equals 2x, and we're going to graph y equals x plus 3. Who would like to graph y equals 2x for me? I'll pick you if you don't. Oh, Adam, you got volunteered. You want to graph y equals 2x? Perfect.
Sorry, Adam. I'm sorry. No, don't pick Adam.
Okay,
I was
here you
just
go.
kidding. No. I'm so
What is
sorry.
the x-intercept? Or the y-intercept, I'm sorry. What is the y-intercept? 0. So start there. How about that? And then do you know what your slope is? Good. So you can totally graph this. Definitely.
I'm sorry, Adam.
It's okay. You volunteered him for an easy one, Tyler. Okay. So Adam says our y-intercept is 0. That's where we always start on a linear function. And that our slope is 2 over 1. So he's going to go up 2 and over 1. And he's going to graph that linear function for us. Simple stuff, yes? We got that under control. Now, what I'm going to do, thank you, Adam, is I'm going to draw in the parent function. Because here's what's going to happen. In your homework and stuff, it's going to ask you to compare it to the parent function. You can do it one of two ways for me. You can do it through words, through written words, which I know a lot of you probably won't like that option. Or you can literally graph the parent function on here in a different color. And you can label them so that I know which one is which. This is f of x equals x. And then the black one would be y equals 2x. And now I've compared it to my parent function. So, in word form, tell me out loud, what is the difference between the parent function and the function we just graphed? What's going on? What looks different there?
There's a Y.
Okay, the y and the f of x are interchangeable, so that's not really something to, it's okay.
There's a number.
What number?
2.
Okay, there's a number 2. So what does that 2 tell me?
That is going to go up 2.
That you're going to go up 2 and over 1. That tells me a slope. So what is different between the parent function and this equation is that the parent function has a slope of 1, and this equation we just graphed has a slope of 2. So my slope has changed, and that's all you would have to state. Your slopes have changed, so the parent function.
So the parent function is 1 over 1.
It is because it's the function is f of x equals x, so there's just a pretend 1 in front of there, right? Okay. Who would like to graph y equals x plus 3 for me? Okay. Come on, Tyler.
Wait, do I add x to the I just need
What's
to
your
subtract
y-intercept?
1.
No.
Oh, 3.
3. So graph 3, 0, 3 first. So you're going to graph 0, 3, up 3.
Oh.
Y-intercept. So when I graph a y-intercept, it always depends on my y-axis, okay? And then what's my slope? What's in front of that x, technically? A 1. Good. So you're going to do what? From your starting point, from your y-intercept, go up 1 So you had the right concept, you just have to actually start from the beginning. There we go. Now draw that line. Good, awesome, thank you. So that is the line y equals x plus 3. Okay. If I draw my parent function on here, my parent function never changes, it's still this. Okay. This is my parent function of f of x equals x. What do I know is different between those? The y-intercept is different, okay? So instead, my new function has shifted 3 units which way? Up, okay? In your book it's going to say, compared to the parent function, the graph has shifted 3 units vertically, okay? And the slopes still remain the same. So it's just going to compare it that way. You're just telling me the differences between them, okay? In your homework, you're going to have to tell me through written words on some of it, and then on some of it you can draw a picture next to it. Kind of depends, okay? So that's how we would word that. Can we get in the habit of wording things that way, okay? Slope-intercept form. Slope-intercept form. What is the equation for slope-intercept form? Yes, y equals mx plus b. Y equals mx plus b. And when we go to graph y equals mx plus b, which is what form this one was just in, okay? When we go to graph that, we have a set of steps that we need to follow, okay? The first one is to write the equation in slope-intercept form by solving for y, if it's not already there. So, write equation in slope-intercept form by solving for y. Step 2, okay, is identify. Okay, identify. What do you think I'm going to identify? The slopes and the intercepts. Yes, I'm going to identify the y-intercept first, okay? Identify the y-intercept, which is my b, okay? Identify the y-intercept and use it to plot the point. To plot 0, b, okay? Because we're going to represent y-intercept in this right now as b, where the line crosses the y-axis. Okay. Step 3. Step 3. You're going to identify again. Okay. You're going to identify the slope this time. Okay. Identify the slope, which we represent with the lowercase m. Identify the slope. Okay. And use it to plot a second point on the line. And then the fourth and final step is draw. Draw a line through the 2 points. Okay. This is all stuff you've done, but there's the written explanation of it and the steps so that you can remember when we get into more difficult problems. How's that? Okay. So then they want us to graph this equation over here. Graph y equals negative 2/3 x minus 1. That's in slope-intercept form. Okay. So how or who would like to come up and graph? Mallory, want to graph it? Okay, Mallory, what's your first step for us? Good, so we get to move to step 2 then. What's step 2? Plot the y-intercept. In this case, what is our y-intercept? Negative 1. 0, negative 1. After step 2, I'm going to do what? plot the slope. Okay, what's my slope? Negative 2/3. There you go, perfect. She went down 2 and over 3 to the right. And then the last step, draw a line through it, boom. And she has graphed it. So all you need are those 2 points when you are in slope-intercept form. Thank you, Mallory. Okay, so perfect. That's how we're going to plot slope-intercept form. Okay. Let's say they give us some word problems with this, though. Everybody likes word problems, okay? And that's what this blue part is. I'm going to read the word problem to you, and then we're going to discuss these steps. It says, the body length, y in inches, of a walrus calf can be modeled by the formula y equals 5x plus 42, okay? It says where x is the calf's age in months. So x is the calf's age. This is its age, and this is its body length, okay? That's hard to write. Okay, body length. And it wants us to describe what the, it wants us to graph it first, then describe it, and then use the graph to estimate. So, Isabel, you want to graph this for me?
No.
No, this one. Okay. Are you going to count by ones, Isabel? Probably not. What do you think we should count by?
2s and 5s.
I'd go at least 5s. At least 5s. Okay. So where we got to start with the equations in y-intercept or in slope-intercept form. Now identify y-intercept. What's your y-intercept? 42. So 0, 42 is what you're graphing. You could go by 10s, yes. You can go by 10s. Perfectly fine. You could go by 20s even. Okay, my advice to you is count by large numbers if there are large numbers. Count by whatever it is that makes it easier so that your graph is not massive. Okay? And you can count your y and x axes by different numbers if you would like. I don't think you're going to deal with negatives because I can't grow negatively.
Okay.
Okay, so go ahead and graph 0, 42. Okay, and then you are going, what? What is our slope? 5 over 1. So 5 plus 42, going up 5, which would take us to 47, 2, right? Okay, and we can graph that line, right? Because we only need 2 points. Awesome. Thank you. It says, describe what the slope and y-intercept represent in this situation. What does the slope represent in this situation? Does anyone know? Thank you. Or what does the y-intercept represent in this situation?
Starting.
Okay, it's our starting point. Okay, the slope 5 represents let's see here. We're talking about a walrus that's growing. Yes, walrus that's growing. I can't say that. And so if it's growing, that means it has to relate to the walrus somehow, like what our intercept and what our slope represent. So what would the slope represent? What's another term we can use for slope that we talked about yesterday with the tree?
Rate of change.
Yes, good. So this slope is representing its growth, its rate of change over the years, okay? So that's good. Good job, Tyler. And the y-intercept 42 represents a newborn calf's body length in inches. It's just the starting point of a newborn. They're roughly 42 inches long, okay? Now, could we use this graph to estimate the body length of a calf that is 10 months old?
No.
Yes. Yes. All you have to do is this. And if this was on perfect graph paper, it'd be much easier to do it. But if I go up from 10 to where it crosses, I can figure out what this point is, and that's my estimation, my approximation. Does that make sense? Okay, so in this case, the book has it graphed on an actual graph, and they said it's about 92 inches because they're counting by whatever. And it's going to be more evenly spaced and correctly spaced. So that's all you would have to do is just draw a dotted line with a straight edge up to where your graph meets, and then you can estimate it. Okay? You could also estimate it by plugging 10 months into the x and getting an output for the y. You can do it algebraically. You can do it graphically. Okay? Okay, last thing we need to talk about is standard form. What is standard form of an equation? Does anyone know what the standard form of an equation is?
Isn't it like x plus x equals y?
No, not x plus x equals y plus 1.
Oh, x plus y.
It's what? X plus y equals what? Kind of. So Isabel's saying without numbers, it has x plus y equals something.
Oh, it's x squared plus y.
Nope, that's going to be quadratic. We're talking linear. So standard form looks like this. They put a here to represent a letter. Ax plus by equals c. Have you seen that before? Okay, that is our standard form. Okay, our standard form of a linear equation is ax plus by equals c, where a and b are not both 0. Okay, and you can graph an equation in standard form by identifying and plotting the x and y intercepts. Okay, an x-intercept is the x-coordinate of a point, where a graph intercepts the x-axis. So step 1 for graphing these, okay, just like we have slope-intercept form steps, step 1 is to write the equation in standard form. Okay, step 2 is to identify. Okay, and it's identify the x-intercept by letting y equal 0. You remember doing this at all? And letting y equals 0, okay? And then you have to use the x-intercept to plot the point where the line crosses the x-axis. Then, step 3 is identify. This time you're going to identify the y-intercept. By letting x equal 0. And then you're going to plot the point where the line crosses the y-axis. Okay, and then finally, the 4th step, okay, just like the 4th step over there, is draw a line through the 2 points. Okay, so on your homework tonight, I personally always like to put stuff into slope-intercept form and graph it from there. I think it's easier. But they're going to be specific and ask you to graph something in slope-intercept form, and then they're going to ask you to graph it in standard form. So follow the instructions, do which one they ask, because you need to know both ways. Okay? So we're going to graph 5x plus 2y equals 10 in standard form. I will graph this one, and then somebody else can come up and graph these for me. How would I graph 5x plus 2y equals 10 in standard form? What do I need to do first?
Change the x to 0. Oh, no, change the y.
Okay, we'll change a y to the 0. We'll find the x first. So 5x plus 2 times 0 equals 10. So 5x equals 10, so x equals 2. So that point is 2, 0. Okay? Now, I have to identify the y-intercept by letting x equal 0. So 5 times 0 plus 2y equals 10. So then 2y equals 10, and y would equal 5. So my point is 0, 5. There's that. Now I connect my line. Boom. Done. Okay, can we do that? Can we handle that? The last type of graphing you have are just straight up horizontal and vertical lines. If something is set equal to just a number, like y is set just equal to 2 or x is set just equal to -3, it's either going to make a horizontal or vertical line. Does horizontal go with x equals something or with y equals something? Who knows? With y. Good, Jeremiah. So if I have y equals 2, I'm coming over here to where 2 is, right? Y equals 2. And I'm graphing that. And I'm going to graph that line so that I can see what is going on. Ugh, I'm being stupid. Why am I on the x-axis? I'm going to go here to where y equals 2 so that I can graph my horizontal line. Okay, y equals 2. If I go to graph x equals -3, I'm going over -3, and I'm graphing a vertical line. Okay? That is what we are working on tonight on our homework. 2.3, graphing equations of lines.